everybody. Hope you're having a great Tuesday. I'm Chief Meteorologist Jennifer Valdez. I'm so glad you are joining me for today's World of Weather. I'm popping you up as we speak on our CBS Facebook page. I'm going to pop you up here so I can watch along and answer any questions you may have. And so I see you. I see me, that means I see you. So let's get started. Today we are talking about the winds and what causes the winds. You may have noticed on Sunday we have a wind advisory, and that happens when we have those strong gusty winds. Those trees really start to move, and a lot of times, even without severe weather, we have winds strong enough that we topple trees and power lines, and we see some power outages. So we're going to talk about what causes the wind. We're going to talk about why sometimes the wind is stronger than other times. And we are going to talk about how strong the winds need to be to do certain things, like knock over trees or move a trash can or move a leaf. So we're going to talk about all that. If you ever wondered what causes the winds, this is the lesson for you. Of course, I will be answering any questions, so feel free to ask anything you would like on our Facebook page. And also, I would love it if you would share this or tag a friend that may be interested in the winds, because it surrounds us all the time. We see it all the time, but a lot of you probably don't know why it's happening. Now, tomorrow we're going to see some gusty winds. We have a cold front moving through, and then the day after, even behind the front, we'll see some wind gusts up to 25 miles an hour. So you're going to feel these winds over the next couple of days, and we'll talk about why and what that means. But first, we want to talk a little bit about the atmosphere, what is causing these winds, and then as always, I'm going to show you some really cool graphics to help explain. But basically what happens, we get winds when there's a difference in atmospheric pressure. That sounds complicated, but really it's not. High pressure always wants to go to low pressure. And the way to visualize that is imagine a cramped bus full of people where every seat is taken and you're all like this, or a cramped airplane, a cramped bus, or a cramped classroom. That is high pressure. Everyone's really tight together. That's how high pressure is. And then if someone opens the door to the bus or opens the door to the airplane or your classroom, how everyone wants to get out of that really, really compact atmosphere, that's because it's low pressure on the outside of the bus or on the outside of the classroom. So all those molecules, just like you in a cramped bus, want to get out. That's what happens with high pressure and low pressure. You always want to go from high pressure to low pressure because you're releasing that immense amount of pressure. So high pressure always goes to low pressure. Now, the bigger the pressure difference, the stronger the winds. And that holds true. That is similar to a bus. If you've got a lot of people in a bus, the more people you have in a bus and you open that door, the faster those people want to get out of there. So that's how you can remember that. The more pressure, the bigger the pressure difference, the stronger the winds. You're always going from high pressure to low pressure. So those are the basics of why winds happen. So now I'm going to turn this around and we're going to explain it a little better. Sometimes with something that you can't visually see, it's hard to understand. I totally get it. But we're going to make it easy by showing you these really cool graphics here. And this is going to help you understand the difference between the winds, what makes them strong, and why they go from high pressure to low pressure. So we are talking about the wind. First of all, what causes the wind? And this is what I just explained. Whenever you see an H on a weather map, that is high pressure. The L is low pressure. And you're always going from high pressure to low pressure. Now, around high pressure, we have a clockwise rotation. Around low pressure, we always have a counterclockwise rotation. What that means is it's like a clock. High pressure, the winds are always going like they do on a clock, from 12 o'clock to 3 o'clock to 6 o'clock in that direction. Low pressure is the opposite. The winds are always going counterclockwise. Now, this is in North America because of the Coriolis effect. Basically, it's because of the spin of the Earth. But did you know that south of the equator, so in South America or in Australia or those countries south of the equator, it's actually opposite. South of the equator, high pressure is counterclockwise and low pressure is clockwise. So it all has to do with the spin of the Earth. So again, high pressure for us in the United States is clockwise, low pressure is counterclockwise, and you always have those winds wanting to go from high pressure to low pressure. Now you have the winds wanting to go to that low pressure. On top of that, you have a low pressure nearby. We talked about the closer they are to each other and the stronger they are, the stronger the wind. So that's what causes wind. So you'll start noticing on windy days when you watch my weather forecasts, or if you look at something called a surface map, and a surface map is where you see the actual fronts and the high pressure and the low pressure, you'll notice that on windy days, we have very strong high pressure or low pressure, and they're very close to one another. And that's what causes those strong gusty winds. Now, your trash can, it's outside. Normally it's totally fine. There's little to no movement. But as the winds start to pick up, you start to see things moving. It can be tipped over nearby. It can go in the neighbor's yard, or hey, it can go all the way down the street with really strong winds. And it all depends on how strong those winds are. And this is a good scale you can use. If it's between 5 to 10 miles an hour, and that's what we normally see on a day, is 5 to 10 mile an hour winds. In fact, today, our winds will be from the south at 5 to 10 miles an hour. So that trash can is not going to move today. Now, tomorrow, we are going to see those winds start to pick up a little bit. The winds tomorrow are going to be from the south at 10 to 15 miles an hour. But we are going to see some wind gusts up to 25 miles an hour. So in some of those wind gusts, an empty trash can may be tipped over. So when the storms come in, if they stay at about 20 to 30 miles an hour, it could be tipped over. Now, during a thunderstorm, we see those winds really pick up with gusts up to 45 miles an hour. That's when it can go into your neighbor's yard. If we see winds over 40 miles an hour, that's when it can go down the street. And again, that's for an empty trash can. It all depends on how big it is, how heavy it is, but that's a general frame of reference you can use as to how strong the winds need to be to move objects across the yard. Now, depending on how big the object is, how heavy the object is, that's going to determine how much wind you need to move it. But a maple leaf, so a leaf from a tree, 3 mile an hour winds will move it. So you'll see a move in the wind. You'll see them move on the trees with 3 mile an hour winds. Again, 3 miles an hour, that's not strong. We see that almost every day. But you need 28 mile an hour winds to move a 96 gallon trash can. A trash can weighs about 37 pounds. So you need it to be about 30 miles an hour. A person, you'll start to feel the winds when they're up to about 70 miles an hour. Remember, 74 miles an hour, that is a Category 1 hurricane. Anything above 58 miles an hour is considered severe thunderstorm winds. So once you're talking about 70 mile an hour winds, it can move a person. 90 mile an hour winds are going to feel it on the steering wheel, and it could even move a car as it's driving. So the stronger the winds, the bigger the object it's going to impact, and the more it's going to impact that object. When we have severe weather, we see 58 mile an hour winds. That's what makes a thunderstorm severe. Once you have 58 mile an hour winds or stronger, you can see trees come down. Now, usually that is coupled with rain, because when we have heavy rain, it weakens the root structure of these trees, and that's when you see them come down. A normal, healthy tree usually will not come down, especially a big one like this one with 58 mile an hour winds, but it's possible, especially if we have a lot of rain associated with it. Now, what do meteorologists use to measure wind? Does anybody know? We haven't talked about it yet, but do you know what we use to measure wind? And this is a trivia question that we haven't even answered yet, but this is the instrument we use to measure wind. It is an anemometer, and that is a little device we hold in our hand. It has these little devices that spin around, and depending on the speed of the winds, it makes those little devices spin faster, so it measures the wind. It's an anemometer. So that's what we use to measure winds. So that is today's lesson on winds. Again, pressure is what causes the winds. The winds always want to move from high pressure to low pressure. They're always moving clockwise around high pressure, counterclockwise around low pressure. The stronger the high pressure and low pressure are, the faster the winds, the stronger the winds, and the closer together they are, the stronger, the faster the winds. So that's what we're looking at for a windy day. We see them a lot after a cold front that moves through, because once a cold front moves through, high pressure moves in. And as high pressure moves in, that area of low pressure was moving out. And if they're close enough, we see those strong gusty winds. We see them within thunderstorms as well. We get those really strong winds coming from thunderstorms. So that causes strong winds as well. So it's something we forecast a lot in our weather forecast. Notice when we give our forecast for today or tonight or tomorrow, we always have the winds on there. And it's just as important as temperatures. So we're always looking at temperatures, the high, the low, the chance of rain, but we're also always looking at the winds. So our wind forecast is always on there as well. So you know how to prepare for a windy day or a not so windy day and what a windy day means. So I'm going to check here to see if we have any questions. And Wesley, you got it right. Anemometer, good for you. looks like we're actually doing good with questions. Now, tomorrow we are talking about El Nino and La Nina. So if you've ever wondered what it means, how often it happens, what are we in now, what does it mean for our weather here in Georgia during El Nino and La Nina? It's really interesting. We're going to talk about what it means across the globe, what it means for us here in Georgia, and what it means for our winter temperatures. And not only does it affect our temperatures, but it affects how much rain we get in a season as well. So make sure you join us again tomorrow's World of Weather. Thank you so much for watching today's lesson about winds. We'll see you tomorrow at 1:15 as we talk about El Nino and La Nina. Everyone stay safe and have a great day.